Good morning, students. In steric energy equation, we are going to solve the problem related to compressor. Let's move on to the question. Air flows steadily at the rate of 0.5 kg per second. Here it is given as mass flow rate. The mass flow value is given as 0.5 kg per second through an air compressor entering a velocity as 7 meter per second, and pressure value is given at inlet and 0.95 meter cube per kg. That specific volume value is given, and leaving the compressor at 5 meter per second, 700 kilopascal, and specific volume value at the outlet is 0.19 meter cube per kg. The internal energy of air leaving the internal energy of air leaving is 90 kilojoule per kilogram greater than that of air entering, which means the U2 value is greater than U1 plus 90. Exist internal energy value 90 kilojoule greater than compare compared to that of U1. Okay, so we can write it as U2 equal to U1 plus 90 kilojoule per kilogram. Right. So what is the next thing? The cooling water in the compressor. Okay, the cooling water in the compressor jacket absorbs heat from the air at the rate of 58 kilowatt. Right, a compressor is there which is rejecting heat at the rate of 58 kilowatt. Okay, we have to find out the value of work done to the compressor, work done what we are giving to the compressor, and the ratio of inlet pipe diameter to outlet pipe diameter. Okay, so write down the given data and draw the schematic diagram for the given question. Okay, so this is the schematic diagram, and the given data is also included in the schematic diagram. Okay, so volume velocity value, pressure value, and specific volume at the inlet is given. Velocity value and pressure and specific volume value at exist is given, right? Okay. we are taking internal energy at exist equal to U1 plus 90 kilojoule per kilogram. Here the minus sign at heat is indicating heat is rejected from system to surrounding. From system to surrounding. The Pascal means Newton per meter square. Pascal means Newton per meter square. Okay. So what is the difference from previous question to this question? Okay, this question is taken from PKNAT. So இதில் இருக்கக்கூடிய notation என்ன difference ன்னு பார்த்தனா, so for velocity we are taking as V1. For velocity we are taking as V1, right? And for mass flow rate we are taking as W. W ன்றது mass flow rate, right? So velocity V. Okay, there will be some change in notation for different books, right? So we are going to see solution. Okay, so write the Serifson energy equation, substitute those values, right? So convert into same unit. Okay, so and substitute those values and find out the answer. Okay, so when I am writing the Serifson energy equation, this one is mass flow rate. W என்ன சொன்னேன்னா mass small w is denoted as நம்ம என்ன யூசுவலா என்ன notation கொடுப்போம், mass flow rate. So U1 plus V1 plus V1 square divided by 2 plus Z1 by G, right? Plus del dq by dt is nothing but we usually taken as q, and dw by dt we usually taken as w. Okay, so nothing change in this equation. Okay, so இதை நம்ம rearrange பண்றோம். எப்படி rearrange பண்றோம்? Change in internal energy, okay, and change in flow work, change in velocity, change in kinetic energy, and change in potential energy, right? So we are rearranging. In the இடத்துல there is a typo error, there will be a plus, right? Look at here, the units are in kilojoule per kilogram. Here the internal energy unit, flow work and kinetic energy, right, and potential energy, the units are in kilojoule per kilogram. so that we are multiplying by mass flow rate to convert into kilojoule per second. Okay, we are multiplying mass flow rate in order to convert kilojoule per kilogram to kilojoule per second, which is nothing but kilowatt. Since Q value is given in kilowatt, since value is given in kilowatt, we are converting other units to kilowatt, or you can change vice versa, right? So the rate of work input to the compressor is calculated as minus 122 kilowatt, minus 122 kilowatt. So the minus sign indicates that we are supplying work to the compressor. Okay, so next we have to find out the value of the ratio of pipe input diameter to and output pipe diameter, right? So we can calculate this by using conservation of mass. Okay, from mass balance we can write it as A1 V1 by specific volume at inlet equal to A2 V2 by specific volume at inlet. Okay, from this we can able to calculate the from this we calculate the area, the ratio of areas, and then from that we can able to calculate the diameter. All right, I hope you understand this problem. Solve the problems from PK solve similar problems from PK. Okay, so thank you for your time.